Hi everyone, I'm Alistair. I'm one of the co-founders of Naturebytes, and I'm going to talk you through testing your wildlife cam kit. What I've got set up here is actually VNC, so I'm looking at the desktop of the Naturebytes kit over an Ethernet connection, in fact. And what I'm going to show you is essentially all of the tools and applications we've added to your kit, how to test your PIR, so that's the sensor that detects when an animal's seen. We'll test that to make sure you've plugged all of the jumper cables in, and we'll have a look at your camera as well. If you haven't yet got to this desktop screen, the one you can see here, then plug your kit in. So you're going to have to connect a HDMI cable, plug it into your TV, and you'll see this. This is the desktop experience of your kit. And what this lets you do is look at photos that the kit has actually taken, and also configure the kit, so we can add the date and time to it, and we can have a look at how we can test it in some of these scripts that we've added. So let's get started. What I want to do first is actually go into these two folders here, test my camera and test my PIR. I'm going to click down here on File Manager, and I'm going to go through to Desktop. You can see the two folders here. You can also see a lot of our applications, challenges, image library journal, and my cam kit, and we'll look at those in a moment. First of all, let's get testing the PIR. So in this folder, you'll have three files. You've got a Readme, you've got a script which starts the actual program, and you've got a little Python script here that essentially talks to the PIR. So let's just open up the readme.txt file. So this is your readme.txt file. And I won't go into this in too much detail, but essentially guides you through what we're going to be doing when we test the PIR. So have a good read of this. To get started, I'm going to double click on the test PIR.sh script. And it's going to ask me what I want to do with this file. I'm going to click on execute in terminal. And essentially what this shell script does is it stops the Python script that is already loaded, that's designed to take photos. So that's the script that runs when you boot up your kit in the garden. It stops that and it says let's just test the PIR instead. I'm going to fire this, and what's popped up is a little terminal window. Hopefully you can read that on the screen from my recording, but what it says is wave your hand in front of the camera / sensor to trigger your PIR. So I'm going to do just that. I'm just going to lean over and wave my hand, and there you go. You can see that it says GPIO pin 11 is high, and so it's been triggered. And you can see it's low and high if I move my hand around. And essentially what we're doing here is testing that the pin, and that's the pin that you've plugged the yellow cable into, the yellow jumper cable into, we're testing that it can actually detect the presence of that. So when it's high, we can detect that the PIR has seen something, so it's detected the infrared signature, the heat from an animal, and when it's low, it's waiting to be triggered. So here I can see that my PIR is working. If you do wave your hand in front and you don't get anything, i.e. it doesn't trigger at all, go back and check that your jumper cable is plugged in correctly. Make sure it connects to the right pin on the PIR sensor itself, and it's also plugged into the right pin on the board. And the yellow jumper cable actually fits directly next to the real-time clock. So go back into the instructions and have a look at that and just make sure that's working for you. Great, so I know mine is working, so I'm going to go and close that down now. I'm going to go over to my camera folder instead. And in here it's essentially the same. We've got another README file, which you're welcome to have a look through. And we've got two Python scripts, one which tests with the PIR and one which just tests for camera. So I'm going to load the one which says with PIR. And I'm going to do the same. I'm going to execute in terminal. Great. What it's saying there, Python no process found, it's actually trying to remove the original process, the script that loads up on boot, but I've already removed that because I've already run the other test. So it's just saying I couldn't find that to stop, which is absolutely fine. And it's sitting there waiting. So I'm going to wave my hand in front of the PIR, and it said 11 is high, PIR has been triggered, take a photo. And you'll see that it's now dropped back to low, waiting to trigger. And this time I've actually got a photo. So it's taken a little example for me here. Let's load this up. That's a very poor quality image because I'm actually using a Pine Noir camera, which is upside down there. This is a development kit on my desk, and it kind of gives you a hint as to what's coming next in our development stream. But this was just a little test, just to prove that the camera is connected, it is able to take a photo, and I can see there that that's working fine. So that's good news. I'm going to close that. I'm going to close my terminal. And I now know that with those 2 test scripts, they're both working fine. So my camera should be good to go. So let's actually go and have a look at what we can do with that camera. To do that, I'm going to load up terminal. The little icon down here on the left. We'll give ourselves some space. Great. So next I'm going to type ls. Like so. It's going to list the directory for me. I'm going to do cd Naturebytes. I'm going to list that. And inside here you'll see the 2 folders, scripts and support. Support basically has all of the files in for the applications, which we'll look at in a moment. For now I'm going to go into scripts. And it's case sensitive, so look out for that capital S on scripts. So cd capital S scripts. And in here I have 4 files. One of them is just a logo. That's what we actually stamp onto the image. One of them is a Python script, nbcamera.py. And the interesting one for you is Naturebytes camera log. Now this is a log that holds all of the processes that the camera is going through, and it's very useful for you to have a look at that to see what it's doing. If you speed up the camera, i.e. you don't want to save to USB, there's going to be scripts in the future where we can save to the SD card, and already it's been some really nice feedback from the community saying that they'd like to do that too. But the log file is quite interesting for you because it'll show you what the camera's doing. And what we can do is we can tail the log file, which means we can look at what the log file is doing. So essentially it's like a text file which accumulates as it runs. We can watch it in real time. So I can actually go tail, T-A-I-L, space, -f, which is the file, Naturebytes, _camera _log. And you can see there that it's reading the log. It's saying that the wildlife cam was started up successfully. And this is me, 829. And it's taken a photo and it's waiting for a new trigger, which is great. So let's leave that terminal window open, and we'll open a new window. So go down, just press again. So what I want to do is actually start up that script that we cancelled when we did our tests, which is the main script that takes photos. So again, let's do ls, see where we are. Well, we want to go to Naturebytes, cd Naturebytes. We're in the right place, yes we are. Okay, cd scripts. Great. And this time I'm going to load that Python script, the NB camera. And you don't have to do this. When you boot up your kit, it automatically does this for you, and we use a cron job to do this. So it checks for that script and it loads it, which means when you place in the garden and you turn on your kit, it's going to work. It's going to run the script and it's going to start taking photos. So in this case, I'm going to type in superuser Python to tell it I want to use Python, nbcamera.py. I'm going to hit enter. Great, and you see in the left there that the log suddenly jumped up and said Naturebytes Wildlife Cam Kit started up successfully. So let's give it something to do, let's trigger an event. So I wave my hand in front of it, it says PIR trigger detected. I can see the command on the right, it says raspberry still, which is the actual command line we use to take a photo. And on the left you can see there that it's taken a photo taken successfully, it's given it a timestamp. It then informs me it's going to use image magic, which is what we use to stamp the actual information onto it, the date and time. It said that it's added the overlay text successfully. It's now adding the Naturebytes logo, so it's crunching through that process. And in a minute, it's going to come back and say, great, I've reset and I'm waiting for another trigger. So there you go, logo added successfully, waiting for a new PIR trigger to continue. And that was probably, what, about 5 to 6 seconds of processing time there. Now, obviously, you could speed that up by just not stamping the photo. You could just have a blank photo, but the date and time we thought was quite useful to have on there. And of course, you can customize this. You can actually go into the script yourself, the nbcamera.python script, and you can change the text. So in the bottom right corner of the image, you'll actually see that it's got camera 1. In fact, let's go and have a look at that. Let's just cancel this now. Jump out of that. And let's go into our image library. You can see here I've been taking lots of test photos through our development time. There's quite a few in here. Great. And what we want to do is have a look at our photo that we've just taken. There we go. It's going to load up a little bit bigger. So you can see here, this is my upside down camera on the Pi Noir again. I've got the logo top left, Naturebytes Wildlife Cam Kit bottom left, the date and time has been stamped, and I've got camera 1 in the bottom here. And we put camera 1 because you may want to use multiple cameras in the garden, so it makes sense so that you can actually name it in the file. Or you could put your own name in there. You could actually name it yourself, your kids could put in what they want there. It's a nice little personal touch. And if you want to see how you can do that, well, let's have a look at the actual Python script itself. So we'll jump out of this, go back to our scripts. This is the one I cancelled, and let's have a look in that file. So let's do sudo nano, so sudo space nano, nano. I'm going to say that's a text editor nano. I'm going to say the file is, so that's dash file, nbcamera.py. Great, so this is the actual code, this is the Python code that your camera runs when it boots up. And have a look through this, because what we've done is written a number of comments, so code commented this to try and explain what's going on and give you a good chance of understanding that if you're a beginner. And of course some of the experts out there will see straight away that they can really get stuck in and make improvements too. Next what we want to do is have a look at the actual code that stamps the photo. So I'm going to rush right down here. And you'll see that at the bottom we've got overlay. So it says overlay plus equals, and in here this is a script that essentially writes information to it saying that it would like to stamp text into the photo and the Naturebytes image. You can see here that I've got text, Naturebytes Wildlife Cam Kit, date and time. And if I go all the way over to the right, you'll see camera 1. And essentially you can change camera 1 to your own name, save the file, and it will stamp that onto it. So it's a nice little touch. You can actually have a play with that as an early start. So this brings me to a bug, in fact, that we found yesterday from one user. You would have noticed when I tested the kit just now, we didn't see in the top left corner the image flash up as a preview. Essentially what we did recently is we added this functionality to save your photos to USB. And we did that because it's a hell of a lot easier to get your photos off the USB, pop them onto a normal Windows PC, and upload them. Users that were beta testing our kit said that they really liked that feature. In fact, everybody did. So we added that to the system. And at the same time, we actually added a preview. And a preview essentially says to the camera, when you're taking a photo, display it on the screen. We display it in the top left corner. Now, you didn't see that in this version because I've actually disabled that preview. I'm going to show you where I did that in the code. Make this a bit bigger for you. Okay, so the bug that's been reported is that the preview window that shows up on the top left of the screen, on the A+, the Raspberry Pi A+, there seems to be an issue where if you're using preview, the CPU can get stuck at 100% and it doesn't finish saving the photo. And this is only on desktop, so your kits are all fine when in the garden. They're whirring away nicely, and we've had some great photos and reports, all that's fine. And because we added that preview feature quite late in the day, it's popped up as an issue on the A+. Strangely enough, only on the A+, on a B+, or on another Pi, it seems to be fine. So we're going to investigate it further. But for now, obviously you're going to want to get stuck in and have a look at how you can solve that problem of the Pi using up all the resources and getting stuck when in desktop mode. And essentially it's going to do that if you were just navigating around on the desktop and you accidentally triggered the camera, it can freeze the Pi on the A+. So we're going to go and fix this. And you fix it here. So you'll see the line here that starts with a comment using the Raspberry Still library to take a photo and show that a photo has been taken in a small preview box on the desktop. So you can see that red hashed out line there. And the command underneath it says Raspberry Still. It then defines the size of the photo, and it used to say preview and it would have some code with the size of the preview window. I've changed that so it's -- no preview, and then I've saved the file, and this corrects the bug on the A+ and prevents it from essentially using all the resources up at that state. So what I would suggest is you go along in your code, you'll see that it doesn't say no preview, it says preview, and then it has a few variables to the preview window size. Just copy exactly as I've got it there. So change the text so it says -- no preview. So -- no preview. Then there's a space, -O, and then it states it wants to save it on the media, which is the USB drive. And once you've written no preview, just hold Control and O. You'll see that it'll say in the bottom corner here, file name to write, same name, nbcamera.py. I'm going to hit enter. And it says wrote 112 lines. Great, so that's updated now. I can then do Control X, and it's going to jump out. So from now on, when my camera boots up, it won't use the preview. So when I'm in desktop mode, the bug isn't going to be present, and it's still going to be exactly the same for the camera in the field, because we don't actually use desktop anyway. It's in the field doing its job, plugged into the battery. Great. So definitely edit that if you're finding any issues with the A+, and obviously in future releases, we'll make sure that's in there until we investigate that issue further. Great, so let's have a quick look now at the applications we've been embedded into the desktop over here. So I'm going to go over to My Cam Kit and load that up. So you'll see here when it loads a little welcome screen. Have a read of that. An inventory in the next tab. This is just to make sure you've got everything that's in the kit. You may have the kit with no internet connection, so you may want to have a look at this yourself and make sure that even if you were past this second hand, you've got all the bits that go with it. And a quick note is all these links here, naturebytes.org/kits/wildlife cam kit. These are all going to come online in the next week. Essentially, we all pushed all of our resources into shipping the long-awaited kit itself, and everything's on our dev server waiting to be pushed live. So we would have hoped to have had that obviously sitting there open for you, except we really wanted to get the kit out the door. As you know, our original delivery date was December, and we're now sitting in May. So we're really glad we did get it delivered, and you'll see all of this come to life, and the community and all of the great functionality we're building over the past few months will soon be accessible. So next, testing your PIR. This is going to take you through the process I looked at originally. That's just making sure your PIR is connected properly with a few tips to check. Same with the camera. So this will go through and literally let you get access to the test script and kind of guide you through that. A little bit of information about placement with some tips, how to place the camera, looking out for the glaze of the morning, afternoon sun, etc. So have a read through that. Same with power, a few kind of tips on how long it's going to take to charge, what to look out for from an LED perspective. And interestingly down here, this is a good one, automatically shutting down the kit. Yes, you can do that. So there's a pin that we've soldered on the power boost, the LB pin, low battery pin, and when the power boost detects that the battery is below 3.2 volts, it will light up that LED. So you can physically see that when you open the case in your garden and you know that it's time to charge. However, we can also connect to that pin and read it. You have to get a diode to read it, because the pin itself isn't natively stuck at 3.3 volts. It actually is connected to the battery voltage, which is going to be higher on a lithium-ion battery. So we have to pull that voltage down, because we don't want to send anything over 3.3 to the GPIO pins. We're going to have a little guide how to do that, and to help you, we've code commented in all of the pin functionality into the script already. So you can just uncomment that, it will connect to the actual power boost and read the data. You just need to physically get a 50 cents diode and potentially 2 jumper cables. So have a look at that guide when we publish it, and it's a nice little extra activity for you all to do. And then of course online. So this is where a lot of the action is going to take place soon, our online community. Keep in touch with us there. You'll see a lot of functionality come out shortly, and this will guide you through what you can get from the online community. Great, so let's just close this down. So you saw I used this earlier on in the testing presentation. Image library essentially is a shortcut to your USB drive, and this just takes you through and shows you all those photos that you've been taking. You can see all mine there. Challenges is interesting because this is another little simple GUI. But the reason we've used these GUIs are because they're Python, we can actually, in the future, when you're connected to the internet, load content into these spaces. So if we were to have an active challenge, for example, we're looking for kingfishers or a species in your place, your neck of the woods, globally, then we can have a list of challenges here, and you can subscribe to the challenge directly from your desktop when you connect to the internet. It'll be like a nice place that we're gonna develop. So that's going to be a feature that you'll see get developed on over the next 6 months, I'd say. Mostly our challenges are going to be posted on our website at the moment because it's nice and accessible, but we really like this idea of connecting directly to you on the desktop, so we're going to do that through this beginning application. And of course that's the same for journal. It'd be great if you could, from your desktop, write in your journal and it will appear on the Naturebytes website. For now, pop over to Naturebytes website and you'll see that the journal will become accessible, and you can have a little play of that. And we'd like you to kind of tell us about your experience. And it doesn't have to be just for species you've seen, but even, for example, I tried this hack or modification, or I found this issue, or I think it's great if you do this, or perhaps potentially even the food you place for your birds and what works best to attract a certain species. Write your experiences in your journal. Others can see that you can share your experiences with others to help them if they may be a beginner. And it should be a really nice place for you to have your say about your use using the camera trap. And that lastly takes me to my submissions. And this is where we're going to allow you to upload your photos to the website. So you can share your sightings. We can run some really nice citizen science-based experiments where we can have a look for the same species in local areas, regional areas, etc. And essentially it's your space too to kind of show off and share what you've spotted. We're hoping it won't just be birds, it'll be all manner of species and even environmental change as well. I know some people want to change their kit to do time-lapse so they can watch how a park changes over time. Changing of the seasons is a really nice idea. And remember that your kit can be powered indefinitely. There's a bung, a neoprene bung at the back. You could run a cable into that to power it in your garden if so. Or you could even switch out the Raspberry Pi, put in a B+ or something with an Ethernet port and run it power over Ethernet with a hat on top. So lots of options there. So that basically wraps up our little testing presentation. If you do have any more questions or any issues, then jump on the website. Alternatively, email us at info@naturebytes.org. And we wish you the best of luck testing and building your camera.